Hi, my name's Kendra, and this week I'm going to go over two different solutions, very similar, two different methods at arriving to the answer. The first one I'm going to go over is Zach's method. He chose the traditional way to do it, which is to plot the points on a graph and by hand and show how to do it that way. He decided to solve for the equation, finding the slope for the two lines, getting a linear equation for both lines, setting them equal to each other to find the point where they cross, and here he found that x equals 60. So he took x equals 60, plugged it back into one of the equations, and found that y equals 15. So for the first problem, where the poles were 80 feet apart, he found that the point was 60, 15. For the second 120 feet apart, he did the same thing, finding the slope of both lines, the points 120, 0 and 120, 20, and the two original points we used the first time, found the slope, found the equation, set them equal to each other, solved x equals 90, and plugged that back in to find that y equals 15. So for both the 80 feet apart and the 120 feet apart, they were the same answer. The only thing I would do different with this graph would be to have two different graphs. Put the 80 feet apart on one graph and the 120 feet apart on a separate graph. I think, while I understand his numbers and method here, I think it might be a little bit more difficult for a student who's just learning this to understand all the numbers and everything that's going on. And the fact, for the second line here, he just drew dotted lines, whereas the first one he drew solid lines. So I think it's a little unclear, and maybe having two separate ones would work better. And that takes us to the second solution, which is Jess's. He looks like he went about it the same way, solving for two linear lines where they cross. And here he has the 4 points, the 80 feet apart for the flagpoles. Using GeoGebra, he plugged all the information into the computer, and here on step 4 found the points of intersection, which were 60, 15, the same points that Zach found, but here it's a different method, and I think it shows a little bit clearer on the picture. And then just for 120 feet apart, he did the same thing, solving for where they intersect, getting the same answers, just two different ways to look at it. One's using technology, one's using the traditional graphing it by hand. Obviously same answer, we hope to get the same answer, but I think this gives students a way to incorporate technology like this, which wasn't around when I was in school, and I think it can help them understand the equation and maybe get a better feeling for solving linear equations.